Okay, so I'm bored here, so we're going to work on the layer effect system. So the system we need to render two lasers, and then we're going to start on that. I can't promise we'll get it working, can't promise we're going to get very far with it, but with the only thing for me better to do is to do homework right now, this seems better. So the effect system is going to need to be created inside Volt's engine itself. After all, we want to be able to use this for everything, including missiles and explosions and machines. Particular machines will actually probably get the most use out of this eventually. So client, this is a JSON based system still, and we're going to need to figure out some way to spawn this, so that way we can do some things with it. Okay, so we're going to remove this off the back. The reason we're going to remove this off the back here is I'm going to read in the NBT in a different way here in a bit, which means we're going to get rid of the requirement for it here, because I mean we're just passing in an empty NBT right now. I believe we check null. Yeah, we check null. So we're good there. And we're going to implement the injection system on the global here. So what we'll have is we'll have a empty constructor, and then we'll have one that takes a class. And it'll be a class that has to extend iJSON gen data. So we could do this, we'll go class extends iJSON. Actually, we'll do it this way. If we put D here, I think it'll work. In theory. So how do we want to handle this? We're going to want to open up one of the other processors that we already have. So this is going to be, actually I can go open the block processor. I was like, I'm trying to think of like what processor to grab, and it's like, oh, well, the block processor does exist and it's down here and it's closer. And this one already has the two things we want in it, which is the debugger. We're going to start initializing the debugger for the global system, and then that way we can actually recycle this part. So we're going to get rid of this, because everything extends the JSON processor, because the JSON processor actually handles pretty well. And we just need to make sure we call this, and then we need to initialize the key handler. So we're going to get rid of this, and we're going to create this in here, and we're going to go super block base.class. Or actually, block property data.class. And this is where shit gets retarded. The reason I'm saying that is because we're handling the block property data here, but this requires something a little different. We're going to want to control Z this. The reason I say that is this needs its own little key handler, and we're going to rename it. So we're going to call this block property. We're going to call it block prop data handler. In case we want to come back through, because there is a possibility that we'll go in on block base and we'll implement some direct JSON injection into the block base. I don't know if I'm going to do this or not, because of the fact that 1, 8, 9, and 10 have their own little version of block property already. This is not where I got the idea. I actually had the idea way before this. And I feel stupid that I didn't go and look at their version before I made my version, because I don't know if the two are compatible with each other. And I'd rather not increase the overhead I already have. But this is not what we're doing for this video. So I just wanted to make sure we maybe initialize this a little bit. So we have that. We want to put this in here. And this will just grab the class, so we'll pass in the class. And we're going to need to copy something out of the block processor because I didn't think about doing this. And this will be called process additional keys is what this is going to be called. So be protected void process additional keys. And then we're going to pass in the pass in an object to inject, and then we want to pass in the JSON. So this will be JSON data. And we're going to copy this and put this down here. So this is going to be called block data, of course. Block property data is what this is. We're going to rename this stuff, by the way. I'm putting it here. And then we want to make sure we pass in the list of objects so we can add any generated objects to that. We then want to pass in our block base. And then what is that third thing right there? So it's a JSON, no, process unknown, metadata. Okay. Does metadata really have a separate handler for this? Apparently. So we'll put this down here. This will be process additional keys. And we block property data, block, and object list. Then we're going to put an override above this, and then we're going to copy this, and we're going to put this up into our super object, which will be the JSON. And put it down here. This is going to change to this thing. So that'll be D. And remove that override, of course. And what we're going to do, how are we going to handle this? It's going to have to be called by the subsystem because there's no real way to code it to function properly. Get rid of that. Actually, reorganize this real quick. The block's just going to have its own custom version because there's no way around this. Okay. We don't need this. And then this just needs to be JSON data. Of course, it's just going to have its own custom version because there's no way to correct this to make it work properly. Yeah, but this can be utilized by the super system. And in theory, we could have piggybacked one of these methods and made it tie into here. But for the moment, so we got our effect system. We want to go public effect JSON processor. And we want to go super effect data.class. And then we're going to go process additional keys. So it'd be data and then it'll be object, and let's rename this from that because I don't know why I named everything this way. So this will be effect data JSON. This means we can actually get rid of this. So this can be replaced by a set method. Actually, instead of doing it this way, we'll just do it. Let's rename this. Use endpoint, and then refactor, encapsulate filled. That should work because it should validate as a Boolean automatically. But we can get rid of that key, and we don't have to change anything else here. This is done. We set this up. As long as this system works properly, then it should read in anything we adjust, add, or change to the effect data class. That's the whole reason why I made that system, is I didn't want to keep editing the processors every time I edited the data classes. Okay. So what we're going to do in here is we need to add a few things. One, this is now private, and we need to add a way to inject NBT. And I need to make an NBT processor here pretty soon. So we're going to encapsulate this. So it'd be refactor, encapsulate filled. I hate how everything gets placed in, underneath the toString. I want the toStrings to always be at the bottom. So your toString equal and hashtag or hash code should always be down at the bottom, so that way they're always in the same spot, and then everything else should be somewhere else. I don't think it really matters fully, but it's a bit of an annoyance. So this should be NBT, and then our type is NBT. So actually we're going to call this additional effect data. Yeah, that'll work. Essentially, we're taking a JSON structure, which is kind of how NBT already looks like, and we're turning it into NBT. Both are basically just glorified hash maps. Or tree maps, technically is what it is. Because it would be a branch that branches into smaller branches that then go to smaller branches. It doesn't matter. So we get NBT as our type. We're going to have to supply a processor for this, or this will actually probably crash. Our processor is right here somewhere. There it is. So I'm going to make a new converter. So this would be JSON converter NBT, extends JSON converter. I think I pass back what I'm converting. Implement methods. Yeah, that's how it works. Great constructor. Our key is NBT. And we're just going to go ahead and register this, and we're not going to fill it in at the moment. So this is registered down in the loader here. Right now there's no registry method for it, but it's a publicly accessible system, so people can just dump whatever they want into it. I'll add a proper registry to it. I'll add an API to it later. It's not important because very few people even know that this system exists, and very few people are actually going to care. I misnamed this. There we go. That means that's accessible now. We just have to code it up, and it's pretty much a recursive call is how it would work. So you would go NBT tag compound, NBT equals new, NBT tag compound. Pass this back. Then you would go if element is instance of JSON object, which it clearly is, but we're adding checks just for stupidity reasons. You would then go for map.entry string JSON element entry, then element.entry set, and you would just continuously loop through these. Yeah, so you make a recursive method down here. So it'd be protected void handle. Okay, so every time you would find a new object is always an NBT tag, I think. Okay, actually you would NBT tag compound, NBT. So you do it this way, then you would go if entry.get value is instance of NBT tag, oh no, that's not what we want, JSON object. You would go NBT tag compound, tag equals new NBT tag compound. You would then call handle. You want to pass in the entry.get value because you're handling the next thing, and then you're passing back the tag, and then you go npd set tag entry.get key, and then you pass in the tag. This would be casted, and this is your recursive call system. So you would just call this. So you would go handle element NBT. And the recursive call system would ensure that you went all the way to the bottom. You could, in theory, add nesting support. Okay, I'm back here. So we would keep it. We keep track of a depth check. This is important for the ideal. Is that eventually you would go, okay, there's a limit to how deep NBT structure should be. So we want to go right here to do add depth limit, and then you would just throw an exception if the depth got too large. This prevents people from intentionally making compression bombs and stuff like that that are designed to crash the game. More importantly, are designed to crash servers, because that is potentially something that could happen, especially when I plan to add synchronized content where you can synchronize your content from the client to server and server to client. You could have a server that goes, okay, I'm okay with a client uploading custom stuff, as long as his stuff validates between it. So if you upload a gun, there would clearly be a damage limit. There would clearly be like limitations on what is considered an acceptable weapon. But if somebody uploads an NBT stack, they could crash a server and they could prevent it from reloading again, in theory. You'd have to go in with a map editor and edit out that item. And it could be a scenario where that happens not because somebody did it intentionally, they just may not have known the difference. They may have messed up, they may have misunderstood how something worked, left off a bracket, but that would all need to be handled. But I guess we might as well finish this off. So you would have a JSON primitive, and then you would loop through your primitives. So you would go JSON primitive equals. I'm trying to think of how to actually handle this stuff too. Because there's no, as I found out with how the JSON system worked when I made the injection system, there's no way to tell what kind of number something is. So everything almost always defaults to a double, is how I usually do it, or I default it to whatever type I want to use it for, and everything converts properly. But let's just keep pressing forward. We'll handle things like strings and stuff, I guess. I have an idea how to handle it, but we want to go primitive is number. We then want to go else if primitive dot is boolean, and then else if primitive dot is string. So I think that's all three types of primitives. So this will be, class represents a primitive value. Primitive value is either a string, a Java primitive, or a Java primitive wrapper. So I mean, primitive wrapper would mean an integer is what it would mean, where this would mean int. So, oh yeah, here's all the primitive types: int, long, short, float, double, byte, boolean, char, and here's their wrapper classes. This is the boxing and unboxing system I like to tell people about. Is These are actually really primitives, and then they're boxed inside this in order to function properly. And then Java auto boxes is what it's called, so it'll put it in the box and take it back out of the box for you to use. And that's how it ships everything around as objects. So that's the reason why people say everything in Java is an object, when in reality it's actually not. It's more complicated than that, but it doesn't really matter. So this would be nbt.set boolean, and this would be entry get key, and this would be entry dot, or this would be primitive dot get boolean. And this would be primitive dot get as string. And this, of course, needs to be set string. So when it comes to a number, I need to figure out how to do it. And there's not an easy way to do this. I mean, how does... I mean, Json clearly understands that there is some way to load this stuff in. So when it stores it as a value, which means more than likely it's storing it as this back half. So maybe I could cast it, go check what it is. So if I get it as a number is a primitive. When you look at a number, is there a way... There is no way to tell what it is. And the only way to do this with an automated system would be to try to find the smallest number, but then that has problems. So the solution we're going to have to do is this way. So we're going to have to go string split equals entry dot get key dot split, and we want to split at this right there. So we're going to put in there like a dash or something. You know what? That's probably the best way to do it. We just have to declare the type. So this means string key is split dot 0. So we're going to treat this like it's Scala or something, which you go, and when you do Scala, instead of doing like int I, it's var I int equals your number is how it works. And of course that is not valid in Java, but this is how we'll do it, because then we can do type, and we'll go split 1, and then we want to lowercase our type to save ourselves a lot of time. We keep the key uppercase because there could be an uppercase check or something. So NBT is going to be case sensitive. And there's no check system for this because the only check is at the other end when we go to use the NBT. It just wouldn't use it. We could add some kind of validation system where we know what the structure is, but if we knew what the structure was to start with, so we knew what we wanted our NBT to look like, why not just load it as JSON anyways, and then load it into an actual usable data structure. But our effect system is designed to be ambiguous in the understanding that that data that goes to the other side is unknown until it hits the object, and then the object goes, okay, I need these variables, etc. We could load this all as a hash map. That would have been another option to do the system, but NBT just seems like the best option because it allows you to do trees, it allows you to save bytes, it allows you to do a little bit of everything. And we want to reflect that in this, and we needed to make an NBT converter anyway so we could load up NBT items for crafting recipes, smelting recipes, creative tabs. There's a huge list of what we can do here. So back to this. So I'm done with my speech, so I can let my fingers rest. So we want int dot equals type, or you know, actually, rather than typing this all in, I should make an enum for this. Yeah. No, wait, don't I already... You know what? The weird thing is I think I already have an enum for this. Like enum number. No, actually I'm thinking of it. I think that enum number is actually only used for converting strings to stuff. And to be honest, I think Java already has an implementation of that anyways. We're going to copy this, and we're going to bring it over here, and we're just going to get rid of all this junk in the middle. I'll create an enum later that's designed to understand how to do all this. Can't think of how useful it'll be. We'll do that, and then that will get caught by the super method, so I don't have to list the whole JSON file. And then what we're going to do here is nbt.setInteger, and this will be key, and of course this will be primitive.getAsInt. And then we just have to work our way down here. So we're going to just do one at a time, I guess. There's not a lot of way to make this faster. Get as byte. I believe we can set a byte. I do not know about a short. We're going to find out really quickly. I think the answer is yes, because Minecraft uses shorts to save with. Yeah, there it is. That's good. It should support everything else, though. Just fine. We'll have to do a integer array. And of course, we cannot do big numbers. That's just not something that's supported by NBT and should never be supported by NBT. Cool. Now the only thing we are missing, so we're going to go to NBT real quick and we're going to look it over. So we got tag, byte, short, integer, long, float, double, string. We need byte array, int array. And tag list. So we're going to do this down here. So to do byte array, to do int array, to do tag list. Tag lists will be handled. I'm trying to think of how to handle them because I'm not exactly familiar with our data structure to start with. So a tag list is an actual object that then has a name. So there is a name to a tag list. I want to say we handle them as arrays. So we come down here and we go else if entry.getValue is an instance of JSON array, because that handles our last object. I think that's the only thing left, because I believe there's only elements, objects, and arrays, and then primitive is a subtype of element. Actually, these are all subtypes of elements, but primitive is, well, you get the point. There's not much going to it. So we want to go, and I'm trying to think of how to detect. So there has to be some kind of detection system. So how this would work is we would get the JSON array equals entry.getValue cast of this, and it'd be JSON element equals array.get0. We want to do that real quick. We don't even want to even bother to save it into the data if it's empty. I'm pretty sure, yeah, it says elements.size, and then it's stored as a JSON element system. But what we want to do is we want to go if element is instance of JSON primitive, and then we would go else else it's a JSON object. This means it's a tag list. So we want to go NBT tag list equals new NBT tag list. I'm going to go list dot append. And how do we append this? What is the element? Well, I mean, even though we loaded the first one, we can just do this. So we can go for int I equals 0. I is less than array dot size I plus plus. I think there's an iterator for this, but whatever. We'll do it the old way. And then we want to do handle array dot get I. We want to cast this to, oh, I don't want to do that. Why can't I cast it? And then we want to do something. So we want to do NBT tag compound tag equals new NBT tag compound. Pass tag into here. We want to then do depth plus plus. Here we go, cast object. Okay, that's right. We can't, there's no return on here, so it's literally just tag. That'll handle that. So that handles our tag list pretty much. Actually, we need to make sure we add our tag list. So bbt.set tag. I believe it is just set tag, so it'd be entry dot get key and then list. Yeah, because you can put any type of NBT base into this. That's how tags work. Is NBT base pretty much encompasses everything. So you got NBT end, tag, byte, short. These are all NBT. So if you want to add your own NBT type, you could actually do this theoretically. There's probably special handling to get your stuff to load. I have never tried it, but I think it is a potential possibility. My mom's calling tech support for time order cable. As much as I'm laughing, the reality of it is I probably gonna go call time order cable here later. And the reason I say that is that how do we? Okay, so how we're gonna handle this is list integer int equals new array list. So we're just going to store it as a list and then we're going to convert it to an array. Alright, so grab this again. Then we want to JSON primitive p equals array. You know, it wouldn't be so bad actually if my mom didn't put her thing on speakerphone. Surprised the microphone's not picking it up because I can hear it pretty clearly. Okay, so I believe we just go inst.add p.get as int. And then we want to do r equals inst dot no, I think it's lists. There is a way to auto convert this. Probably was array. It's probably copy of, and there's probably something in here. Oh, what am I thinking? This is, I could do this the actual way. I forget there is a size variable for this. You know, this is actually where I almost wish I had pointers from C. I just learned how to use those things, and I'm actually starting to see how useful they are. Like, literally how a pointer works is you can do something like this, and equals your array, and you can go C++, and it would auto-increment your array forward, so you don't have to do what I did here, which is get your position in the array. So you literally create like a pointer that points at the next element. It's the same way iterators work, but back to our system here. So set int array, we want our key, and then we want R. And we just repeat this whole entire thing for bytes. So we'll have a byte system here, another byte, and we get ourselves as a byte. And then we set byte array, and we just handled every single system we can handle with NBT properly. We just need to put some error code in here. So we go like if else, so for some kind of else here, you throw an exception. So it'd be unknown, actually we want to get entry.get value. So we go unknown type to convert to NBT. So we'll do that there. And we'll go here, unsupported type of, and then this will be type for array read. Actually, how do arrays get stored? NBT byte array. I mean, it stores it as the array. Here's our write function. Yeah, it converts it to a byte stream, I think. So in theory, we could add other types to this. In theory, I could just shuffle shorts in this category. Yeah, I'm not gonna do it though. I'm gonna throw an error if they try to put anything else in here because I don't want to have to worry about anything else. But that'll convert our NBT structure, so that gives us our NBT inject right here. And that took us way too long, so we're at 38 minutes now. What were we gonna do? We need a couple other variables in here. So we need private pause render offset. So this is how we're gonna handle our offset position stuff. So wherever we go to render this and we just want to offset it, we render it. So when we go to render both of our lasers, all we're doing is going to offset a little bit to the left and a little bit to the right. And this is going to be pause.0 by default. And then we're going to encapsulate it, so we're going to hit refactor. I should just memorize the hotkey for this at this point. And then we put our data variable over here. And this would be render offset. And it's a pause. I probably could detect for the type of pause, but I'm just going to use a type variable because it's easier. And when we go to do this, we literally just go render offset.x, and we just add each of the variable to it, and that handles our render offset. So there's no complication about this, just pretty simple code. And we need to make NBT merging. So I don't know how to merge two NBT structures together, and that's the problem. So we need to do this to do merge NBT. So then we want to basically want to go like this, and we want to go if this dot get NBT doesn't equal null, then how we merge NBT? Is there, you know what, I wonder if there's just a system for it. Oh, there's not. We would literally have to read out NBT, and how is NBT stored? Because if we can figure out how it's stored, so it's just a tag map. We can get a set, so we can get the set of keys. So we can get, that's actually a key set is what we can get. Is there a way just to get, I think there is a way just to get the tag. So we could just grab, yeah, because this is direct access. So if we get the key set, so we want to just do this. So we go for, I think it's string, key, get nbt.keyset. Is that not a public variable? No, it is. It's not a readable variable. I'm pretty sure that's just a key set is how that works. Just to be sure, we're going to go if O is instance of string. This prevents weird crashes if somebody does something stupid because they weren't paying attention. Why? Oh, come on. Why have your own string and why call it internal but then let everybody access it? This is where Java needs a version of public that is called package only, where you can go like app package and then this is only accessible inside this package. Maybe I can invent a parser for IntelliJ to make an annotation like that work, or I go Google and somebody probably has one. So when I get key, so it'd be NBT tag base, NBT base tag equals get NBT dot get tag for key, and then what we want to do is if tag does not equal null, because somebody could set null data being an asshole, and we want to go used NBT dot set tag key tag, and that merges our two NBT stacks together. Before we do this, I want to do copy, even though that's probably not a smart idea. Really, there's a, whatever, just cast it. Somebody needs to have done their job and fix that. Okay, this does mean, because of how the merge system is designed, our NBT will take priority over the NBT injected in, which is what we want. And that'll be good. So this will handle everything. We now have NBT, so we can change our colors of our stuff. Doing pretty good, actually. Now we just got to add a layer system. So this handles that. Probably going to crash, actually. That's what that's going to happen. So I probably shouldn't have closed that. Effect data. So we got a position. I think it's literally the only thing we need. Now we just need to create effect layer. Or we need to create an interface. So there's an imp right here. So Java interface. Why did my phone vibrate? Oh, I ran out of food on my one zombie game. Effect data. And trigger. So we just need these two methods. And we're going to make this a default. And this would just be, I guess we'll pass this in too. So make this a default as well. So this is going to be overriding NBT, how this is going to pretty much function as. So get NBT, and then this is going to be one is not going to be default. Yeah, actually, we can make that a default. I don't see why not. Move this down. This isn't even used. Well, it's probably used internally. Is it used internally? Where is this even? So we create some kind of variable here. Yeah, we're gonna just get rid of that. There's no use for it. Cool. Then we just implement Json or effect data. And the reason we're doing this is that in our client data here, we do this, effect data. This will allow anybody to register an effect data system, so they don't even have to use the JSON system to register effects, which is actually sort of important for some people. We're going to leave the rest of this. Eventually we'll come back through and all of this will end up becoming whatever system we want to use. The render state system is already set up that way. But now we want to get effect layer is what this is going to be called. Actually, this is going to be called an effect layer, so we want to call this, rename this. So effect layer. Why'd this error out? More importantly, why? IntelliJ, you're being useless today. It's going to be effect. I'm trying to think of what to call this. So we got an effect layer. Now we need an effect effect trigger, effect pull. Effect list maybe. Yeah, that actually might work. We'll maybe implement this in a certain way. I need to copy these two. I was thinking I could extend array, but then I would have to implement JSON gen, and that I think it comes with its own. Actually it doesn't come with much. So we just do it this way. Because if I do it this way, I can extend array list, and then pass in effect layer. This is going to need its own processor though. I think. Or no, I think we said we were going to do some kind of system. So this will be public. So we want to come over to our effect layer, grab its registry method, call, pass that in. We want to grab this data up here. We don't want the NBT tags. I'm not going to do an overarching NBT system. Nah, we can do an overarching NBT system. And we can do an overarching position setoff. It won't affect anything. It's actually pretty straightforward. We do need to go. Actually, we're gonna extend JSON object. I think it's what we do. JSON gen data. Yep. The reason we're going to do it this way is I don't want to handle all of the junk myself, and we really don't need anything here, so we just need a list that has effect layers in it, and we just do to layer equals a new, because this is all going to be handled internally. Nobody's going to be calling this externally. Okay, so I need iEffect data, and I want this method. So we want to go for effect layer, we'll go layer, layers, layer dot trigger world x y z mx my my mz endpoint and NBT. And then we're going to of course put our system here, which I'm just going to come over to this, and we don't need the provider. We do need this piece. So we need to make sure we are passing in actually pretty decent NBT. So I'm going to use used NBT. So that way we merge our NBT. So we have like a hierarchy system. So we got the NBT passed on the server, which will be merged with our NBT up here, which then will be merged on the next layer down. It's also another reason why we're doing the copy call here, is because this NBT is technically going to be the get NBT call. Why is this not validating? Oh, we forgot this part. So this will be iEffect data. Okay, that works. We'll go back over here, copy this part. That way we got a hierarchy system going on, where we translate by the translate. And this means this could be theoretically nested. And what else do we got going on here? Means we're going to need an NBT system, and we're going to need the inner node. So we're going to need both of these. Put these down. Actually, we're just going to copy the whole thing down here. I want the toString as well. So we want to call this an effect list, and just be key. We don't need the effect key. I don't know why that's there. So we just need a key. We're not going to debug the list, so there's not going to be anything like that going on. You'll just get a key so you know what is being rendered. So if it errors, you know it errored out. What else we got? Looks good. Not seeing anything else I need to toy with this. We can use the same system here. The problem is the processor is not going to be the same. So we're going to make a new processor. So this would be effect list processor. And literally put an S at the end of it. It's going to always be handled as if it's it'll be handled as a JSON object. So you'll have an effect ID, you won't have a key, but you will have something called list, which means this will go away. Get rid of that. This is going to turn into an effect list. Same with up here. Okay, so we then want to put like a system here, and we want to go JSON array list equals effect data dot get as JSON array list, and we're going to go pretty much for each. Wonder if I actually can do it. Oh, it is an iterator. That saves me so much time. Yeah, we'll just call this entry. How to process this, actually? That is actually a really tricky question. That means theoretically this needs to be an instance-based system. So I need to set this to private. I need to go public static final effect JSON processor instance equals new effect JSON processor. And then I can just come over here. Oh, come on. Don't need this. Okay. So each one of these is a JSON element. And theoretically it's going to look like that. Trying to think of what this actually would look like, because we would have each thing would theoretically be an object. Hopefully. We haven't been testing any of this stuff. So JSON object, object, entry, dot, yes, JSON object. We're going to go with object dot has list. Then we want to go data dot layers dot add process object. Yeah, that'll work. Oh, yeah, you're gonna be dumb, aren't you? I didn't think of this through when I made this. So I'm gonna go I effect data. That way I can recycle this as best as possible. And of course I'm gonna have to come through with a better system here later when I get this done and process this more efficiently. Because right now I'm making assumptions of what each of these objects is, and I'm not really checking what I'm doing. There's going to be a problem if I do that. Do that real quick. Cool. There's a bug in the core. What? Huh? Ah, that'd cause a problem. Cool. Process, add. Good. Should work. When we go to render a double-barreled laser, it should do the trick. This actually went together easier than I thought it was going to go together. We're only at an hour. About to call it done for the day. This will be the last video I make. Okay, so that's registered, and then we want to go to our notorious sentry gun here. You know, this actually should be in the render package. It really doesn't matter where this stuff is, by the way, in case you guys are wondering why it is I'm putting them in some packages versus others. The file has literally no impact on this. This is considered an individual piece of data, this is considered an individual piece of data, and they're processed independently. So if the server doesn't care about textures, it won't load textures. It'll still load the file up, so go, oh, we got this file, it contains these entries, but we don't have a processor for it, so we're going to like, I don't care. Okay, use endpoints isn't used anymore. Okay, we got our effect ID. We don't need NBT right now. And we want to call this effects, which means, okay, we still need the key. We don't need an effect ID, but we do need a list object. So this would be list and a razor done with brackets. And they're going to be JSON objects, so they need something like this. You know what's the weird thing about the effect layer? Keys aren't important. Position offsets are, though. So we're going to go key literally is like this. So this would be, we're just going to call it left and right because, I mean, you're going to use the keys as pretty much names at this point. So this would be right laser. we'll quickly reformat that, and then we want to store, what is it called? Close a few of these real quick. I don't need you, don't need you. I actually don't need either one of these. And yeah, don't need either one. I need the offset position. Is that actually what it's called? Yeah, render offset position. This is a position-based system. The cool thing is it doesn't really care if we have all the data. And the cool thing is I believe I added support for these, so I can go 1, 0, 0. That doesn't work. Clearly it doesn't understand how that works. Probably because I need to do something like this maybe? That does work. That does work, that's cool. Okay, so left would be -1. And of course these values are too large, but just for demonstration purposes. We then want to go after the list, and we want to test our NBTs. So NBT, and I put a semicolon instead of a colon there. Okay, so we do have a lifespan tick timer. Right now it is set to 1 inside the laser. So I need to go find the core and figure out what the name of the variable is called. We're not going to set our color right now because I actually really don't care to set the color. It defaults as red, so we're good. The cool thing is I can change the color based on friend or foe, but we'll do that later. Actually, I don't know why I opened that package. Need that package. Core. Nope, client's what I want. What am I looking for again? Yeah, FX. So laser beam. We're looking for lifetime tick, and we didn't even load it. So we want to go other data.hasKey lifetime, and that'd be other data dot. This would be life ticks. And what else do we want to put in here? We got color. We apparently aren't using color. I forgot I had debug code and I forgot to remove it. So this would be load color, load life timer for a particle. This controls how long the particle stays in the world. That's the reason why I wanted this, is it lets me test if the NBT is actually working. So life timer, and then 4. And then what else do we want? There's a couple other variables that the laser does have available to it. So when we go down here, so particle max age, just what we're putting in there is age real quick, is what that is. There is reverse and pulse are two things that are turned on that are absolutely annoying in my opinion. They do work though. So we could turn those off. There should be a size control in here somewhere. Is there not a size control? I'm kind of intrigued actually. I can add one. It's not that hard. It's handled down here somewhere. Okay, here's size. 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 Size is a variable handle. We'll play with size another day because it's not that important. I don't want to mess with it and break the render code because it's used by our debug. You don't want to mess with things that are handled by debug so often. But we got life ticks, and that's how we're going to handle tester NBT. Actually, this isn't called NBT, is it? This is called additional effect data. Called effects1. Got a key. Could have set a load condition on this entire class file, but do that later. Right now we want to hit run and see what we get. Pray we don't crash, because we're at 1:05 right now, and I'm trying not to avoid making really long videos. And do I have any drink? Oh yeah, there we go. It's a bottle of soda. You know, waste times I'm going to go through all my videos and see how many times I say the word Because I mean, when you're sitting here recording, I think about what I'm actually saying, and I actually listen to what I say because I know it's going to be recorded. Unfortunately, that still comes out because I haven't trained myself to think that word, and I'm doing it a lot less than I used to. You'd be surprised how often I would go and you'll be surprised how many times public speakers use the word. But that's not important. You guys are definitely here for coding and not for public speaking and everything else, which I have had some training in, and it still hasn't helped the fact that I suck at it. File is missing effect ID. File is missing effect ID. You are really helpful. Oh, you know what? Where's the processor? Json effects. Aha. This needs to be key. We're getting there. I need to unit test all this stuff still too. I don't know if I'm even going to do that this week. I need to. So that way when I go to update, it's just click unit test will tell me when I'm done. How probably when I go through the 1.8 update, I'll write a lot more unit tests because I'll have to test individual sections of code before I can even get the game to launch. Oh god, it's gonna be pain to get this updated. I'm somewhere over a couple 100,000 lines of code in all my projects. Just so many lines of code. It's where I always keep thinking I should just stick with game development, because if I'm writing this much code, not making no money, not really getting much out of it. I mean, I keep doing it because I enjoy it, but materialistically valued is crap. We forgot to do something. This down here is an int. I'm probably going to have to go look around and see if anybody's got a better way to handle NBT. There's got to be a better way to do JSON to NBT conversion. Although the answer I'm probably going to get is like, why are you using NBT when you could just use something else? And the answer is, I do not know. And the answer should probably be, I probably should make something else. And that's actually what's going to end up happening. Because if I go to convert away from using Minecraft and Forge code, I can't use NBT. There's a lot of things I can't use after that. It's going to wreck a lot of my file systems, though, because I don't know if anybody's paid attention to how the file structures work on some of my mods. I save NBT data to the world, not in the tiles. That's obvious. I'm going to have to continue using NBT for tile saving and entity saving. But all the weapon data, so all the weapons, when you go to figure out what metadata there, that's saved to your world. All my AI stuff saves to the world. So Artilex, they save all their villager data to the world. What else do we use? ICBM saves missiles out of the world to NBT structures. So I'm going to have to create converters to fix all that. It means here in a couple versions, I'm probably going to write a converter and it's going to end up as JSON, because I don't think you guys have that many missiles in the world that you're going to have. If you have more than 1,000 missiles in flight when you hit the save button, I think then there's a problem. Maybe I'll do a byte save system. Come up with my own proprietary save format. I don't know. Figure something out. Okay. You see the lasers, right? See two of them? They're not at all where they should be, but it's cool though. You got two of them. Actually, why is that the way it is? It's XYZ, right? XYZ. My pause converter's probably broken. That's down in the lib. I'm gonna probably take all this JSON stuff and make it into its own little file system here pretty soon. Even though I want it to be the flagship system for JSON or for Volt's engine, it is so reusable that I want to make sure other developers can utilize the system. Because after all, if another developer's downloading it, I don't care. As long as they download it and they don't just fork my whole project and then shove it in their own mod, I'll be okay with that. Okay, we screwed up the array processing. Because this is messed up. Yeah, you're all messed up. Okay. We're good though. I'm going to continue correcting this and adjusting it, and I'll get back to you guys another time.